In this video, we are going to write equations for patterns and solve them. In our first example, John and Heidi are building this toothpick pattern. They have 28 toothpicks that they can use. We want to know how many figures or how many squares they can build with 28 toothpicks. First, we're going to complete the table. In the first figure, there is one square. We have 4 toothpicks. In figure 2, we have 2 squares. We have 7 toothpicks. In figure 3, we have 3 squares, and we have 10 toothpicks. The pattern is add 3, start with 4, and add 3 each time. In the fourth figure, I should have 13 toothpicks. The recursive pattern rule is start at 4 and add 3 each time. Now we're going to write an algebraic expression for this pattern. S is going to represent the number of squares, or the figure number, or the term number. Since we have a repetition of adding 3 each time, that means we're going to multiply that number by the number of squares. It's repetition of adding 3, multiplying. When I do that, 1 times 3 is 3. I need to add 1 to get 4. 2 times 3 is 6, plus 1 is 7. 3 times 3 is 9, plus 1 is 10. I need to add 1. If T tells me what the total number of toothpicks is, I'm going to redo the equation. John and Heidi have 28 toothpicks, so that number would go here. 3 being what I'm doing each time, plus the 1 I have to add. Now, the next step is to solve to find what 3s is. This is the equation. I have 28 toothpicks. 3 times s is 1. This is how we solve it. The 1 will go to the other side, which makes it 28 subtract 1 equals 3s. 27 equals 3 times s. What number multiplied by 3 gives me 27? It's 9, so s is 9. Therefore, how many squares can they build? They can build 9 squares. Now, we're going to use a method which is called solving by inspection. The left side is 28. The right side, 3, is 3 times 9 plus 1. 27 plus 1 is 28. Yes, they balance. Let's do another example. Raina wrote the expression 4n plus 3 to describe the pattern below. N is going to be our figure number. Why did Raina add 3 to the expression? The 3 represents the middle squares that stays the same each time. That number doesn't change. Why did Raina multiply the figure number by 4? Because she adds 1, 2, 3, 4. 1, 2, 3, 4. Repeated addition is the same as multiplication. She's adding 4 each time. Now, we have an equation. S equals 4n plus 3. S is going to represent the total number of squares in a pattern. 4 represents what we're adding each time, or what we're doing to the figure number. N is the figure number. 3 are the 3 middle squares. Raina builds a figure in this pattern. She's going to have 23 squares. So she substitute 23 for the S because S represents the number of squares. 23 equals 4n plus 3. This is how we solve it. The 3 will go to the other side and do the opposite. So it becomes 23 subtract 3 equals 4n. 20 equals 4 times n. I'm going to move this number to the other side. It does the opposite. Equals n. N equals 5. So now let's use inspection to check our solution. 4 times 5 plus 3. 4 times 5 is 20, plus 3 is 23. Yes, they work. Now it is your turn. We have a pattern that has 4 triangles, 4 triangles, 4 triangles in each, 2 squares, 4 squares, 6 squares. Use a table to help you to figure out the pattern. Then you're going to write an algebraic expression. Then you're going to figure out in which figure number will you have 28 squares. Show your work and then check your solution.